You know, every single time you tap your phone, click a mouse, or swipe a screen, you're actually starting a secret conversation with your technology. Today, we're going to pull back the curtain and show you exactly how that conversation works. I mean, have you ever really stopped to think about it? It feels so simple, so direct. You click, something happens. It's almost like magic. But what's going on under the hood? What's the secret sauce that makes it all feel so seamless?
See, that click isn't you just shouting an order into the machine. It's more like you're tapping the program on the shoulder and saying, "Hey, I just did something, your turn." And the program listens. And then it replies. That back and forth. That is the heart of what we call event-driven programming.
Now, this is a huge shift in thinking, right? You might imagine code as just a list of instructions that runs from top to bottom, one after the other. But an event-driven program is totally different. It's designed to just sit there and wait. It waits for something to happen, an event. And that event is what tells the program what to do next.
This is probably the best way to picture it. A waiter in a restaurant doesn't just start bringing you random plates of food, right? Of course not. They stand there patiently waiting for you to decide. You ordering the pasta? That's the event. And only then do they spring into action with your specific request. Our apps, they work the exact same way.
So, if this is a conversation, what's the grammar? What are the basic rules and building blocks that allow a program to listen and then respond? Let's dive into that core structure. Okay, so the foundation, the bedrock of this whole thing is something called the main loop. Just imagine, the second you open an app, this loop starts running, quietly, constantly, in the background. And it's just asking one simple question, over and over and over. Anything happen yet? How about now? Now? It's the program's engine of awareness. And a security guard is the perfect way to think about this. They aren't really doing much, are they? They're just observing, patrolling, watching for any sign of activity, a door opening, a strange noise, or, in our case, a mouse click or a key press. It's all about being in a state of constant readiness. And when you look at the code behind it, it's kind of beautiful how simple it is. This basically just says, hey, as long as this program is running, your only job is to keep checking for events. And if you find one, figure out what to do with it. That's it. That's the entire job description for the main loop.
All right, so the main loop spots an event. Now what? Well, the program needs to know exactly what to do. That's where callback functions come in. Think of them as pre-written plans of action, just sitting there waiting for the signal to be called back and put to work.
I just love this analogy because it's so relatable. The program isn't wasting all its energy constantly asking, is it time to save yet? Is it time to save yet? No, it just tells the save button, hey, you call me back when you get clicked. It's so much more efficient. The program can just chill out, trusting that the callback will happen when the time is right. And here's what that instruction can look like in code. It's so direct, you can almost read it like a sentence. You're literally telling the button, hey, on the click event, I need you to run the set of instructions that I've named button_clicked. You're just setting up the plan ahead of time.
And finally, within this whole structure, you have subroutines. Think about it. A single event like save my file isn't really just one action. It's usually a bunch of smaller steps. Subroutines are just these neat, tidy little packages of code that break a big job down into smaller, more manageable ones.
Let's take saving user data, for example. The program doesn't just blindly save it. First, a little subroutine might check if the email address you entered is even valid. Then, another one actually writes the info to the database. And finally, a third one pops up that nice little success message. It's all about breaking big problems into tiny, logical steps.
All right, so we've got this structure down, but what are the specific tools a programmer grabs from their toolbox to actually build these conversations? Let's look at the key features that really bring this all to life.
So you're going to hear this term a lot, event handler. And you might be thinking, wait a minute, isn't that just a callback function? Well, yes and no. It's helpful to think of it like this. The callback is the promise to do something later, but the event handler is the actual list of instructions. It's the code that handles the event.
So, to make it super clear, think of it like this. A user clicking Buy Now is like them ordering a cake. The event handler, that's the recipe. It lists all the steps in order. Check inventory, process the payment, confirm the shipping address, and send a confirmation email. It's the step-by-step guide. Now, so far, we've mostly talked about events that you start, but sometimes the program itself needs to kick things off, like an autosave every 5 minutes. A trigger function is the piece of code whose only job is to fire the starting pistol for an event like that. It doesn't do all the work, it just gets the ball rolling.
And this is the perfect image for it. Think of a complex animation that starts when a video game level loads. A trigger function is that little push on the first domino. It doesn't have to know about all the other dominoes. Its only job is to start that beautiful complex chain reaction.
Okay, this is my favorite part. We've been talking about loops and handlers and triggers, which can feel a little abstract. But now let's connect it all to your actual life. Because I promise you, once you get this concept, you will start seeing it absolutely everywhere.
Every time you submit a form online, boom, that's a submit event. Moving your character around in a game with the arrow keys, each press is a key down event. That little pop-up telling you you've got a new chat message, that's a message received event. And that autosave feature that just saved you hours of work, that's a timer event. It's all the same conversation happening all around you.
Now, this way of building software is obviously incredibly powerful. I mean, it's the foundation of almost every modern app you use. But like anything in tech, it's not perfect. It has its strengths and, well, its tricky spots.
On the plus side, it's super responsive. Apps feel alive because they're always listening. It's also really efficient. The computer isn't wasting energy on things that aren't happening. But on the flip side, it can be a real headache to debug. Since the code isn't just a straight line, finding a bug can feel like detective work, with clues scattered all over the place in different handler functions.
So here's the big takeaway. Every tap, every click, it's not a command, it's an invitation to a conversation. And now you understand the language of that conversation, the listening loops, the promises of a callback, and the step-by-step replies from the event handler. So the only real question left is, now that you know how the conversation works, what do you want to talk about?